Kirchberg. Since the second half of the 20th century, this plateau to the northeast of the center of the capital has developed into a significant prestigious district. In 1961, the Kirchberg Fund was set up. 2 years later, the building of the Red Bridge connected the district to the city center, the Vilholt. As the infrastructure was developed, European Union institutions and banks moved into the district. In the early 1990s, the area had to be restructured to achieve an appropriate urban density. In the course of addressing this challenge, the whole energy concept for Kirchberg was also rethought. In 1997, a European invitation to tender for the construction and operation of a power plant in Kirchberg was launched. The winner was LuxEnergie, a company known since its foundation in 1990 for its strengths in the area of heating and cooling. The Kirchberg power plant, with its impressive chimneys, is now a feature in the district's skyline. Once commissioned, the plant supplied the Kirchberg heating district network of the City of Luxembourg via natural gas cogeneration installations, supported by condensation gas boilers. The cogeneration installations, which produce not only heat but also electrical power, fed the current generated into the public electricity grid. Due to the growth of the Kirchberg district and the general increase of heat requirements, LuxEnergie began an initial ecological conversion of the energy plant in 2016. Since then, most of the heat has been produced from biomass, specifically wood pellets. The pellets are burnt in a cogeneration installation and the heat generated covers Kirchberg's baseload. During consumption peaks, the additional activation of the cogeneration facilities and, if necessary, the condensing gas boilers made it possible to meet demand. The complexity of carrying out such a huge transformation while keeping the existing production installations in service should not be underestimated. Due to a lack of space in the existing premises, the silo for the new installations was built on an area next to the office block. As a result, the urban planning of the adjacent areas had to be completely reviewed and precisely coordinated with the Koch Arena and Lux Tram. In 2023, the heating plant was converted for the second time. Peak load coverage has now been made more environmentally friendly by swapping the gas-fired cogeneration units for 2 wood dust boilers with a total output of 15 megawatts. So, how does this installation work? The silo allows to store up to 500 tons of pellets, which corresponds to an average autonomy of 1 week. The pellets are produced from local wood by the company Kiawatt in Rust and are delivered 3 to 6 times a day on working days. A bucket conveyor carries the pellets to the upper part of the installation, and from there they are transported by conveyor for uniform distribution throughout the silo. The pellets then fall through hatches onto another conveyor which carries them to the boilers. Precise dosing ensures optimum efficiency of the combustion process. The boiler burns 2.9 tons of pellets per hour. The generated heat converts the water into steam at a temperature of 485 degrees Celsius. A turbine downstream from the boiler uses this steam to generate electrical energy. This process makes it possible to generate up to 23,000 megawatt hours of green electricity per year, supplying the public electricity grid. The residual heat from the turbine is used to produce a thermal baseload of 9.5 megawatts, which provides the Kirchberg district heating network. This installation allows production of up to 77,000 megawatt hours of green heat per year. As soon as the heat demand exceeds the base load, the wood dust boilers are started up. The pellets are first crushed in a hammer mill and then injected into the pellet boiler in precisely metered quantities. As these boilers are used to regulate the heating after the base load produced by the biomass steam boiler, precise regulation is required. These wood dust boilers enable precise control of heat production in a similar way to a gas boiler, by varying their load. Traditional pellet boilers have greater inertia when it comes to the need to vary output. The exhaust gases pass through a high-quality filtering system. Regular emission checks by accredited bodies ensure a minimum environmental impact. The ash and residues are fully recovered and stored pending recovery and recycling by a specialist company. Condensing gas boilers will continue to be used to ensure the supply of heat during major peaks in demand. These two transformations of the energy plant make it possible to save 13.8 million cubic meters of gas per year, which simultaneously means a reduction of 37,000 tons of CO2 per year. The heating network has become a green network, over 90% of which is supplied by renewable heat. With these transformations of the energy plant, LuxEnergie has demonstrated the benefits of a district heating network by converting the entire Kirchberg district to green energy. LuxEnergie is therefore delivering sustainable energy to a whole district and its inhabitants, while making its own contribution towards protecting our climate. LuxEnergie, the responsible energy provider.